So, hello everyone. Our next speaker is Pratap Nair. He is a founder, director, president, and CEO at In General. We'll speak on best practices and case studies of digitalization, business objectives, and technology alignment. So, I'm giving this mic to Mr. Pratap, and he will take this conversation ahead. Please.
Thank you, Vatsal. Um, Before I start, let me just give you a very brief introduction of, Ingenero. We have been supporting companies in the petrochemical refining, basically process manufacturing space, for the last 2 decades, doing advanced analytics for a lot of these facilities. Even 20 years back, we were hooked into these facilities and looking at their data and then doing detailed analytics based on data as well as fundamental principles. Now, the last 7 or 8 years, this has transformed into, with the growth in the whole digitalization model. We've actually been developing and deploying a lot of these digitalization solutions for a lot of our customers. And our customers span, a lot of them are in the US, a few of them in Europe, Middle East, and several other Asia Pacific countries. So with that introduction, I think
Pratap, can you share your screen?
Yes. Yes. Can you see the screen?
You need to go to the full screen of your presentation.
Yes, I have done that. Can you see it?
No, you just need to share the screen.
Let me
go to the presentation form.
Okay. I've shared the screen and then.
Yes.
Can you see the screen now?
Yes, it is perfect now. You can go ahead.
Great. Thanks, Vatsal. So based on our experience deploying and developing these digitalization solutions for a lot of these process manufacturers, we've got a lot of learnings which I'd like to share some of them with you today. What we have found to be the best practices, and then I'll share some case studies. One of the key things is, of course, aligning technology with business objectives, and I'll talk more about it as we go through the presentation. Now, we've gone through several industrial revolutions over the past, several years. The latest being Industry 4.0, as you all would be hearing about of late. And this has really come about because of the tremendous increase in computing power, the speed of communication, data storage capacities, and all of this at a very affordable cost. So you have a lot of technologies like AI, cloud computing, big data, IIoT. All this came out of the Industry 4.0 revolution. And now we're in a phase where we're really looking at monetizing these Industry 4.0 technologies from the results coming out of a lot of these technologies like augmented intelligence, smart data, and so on. So monetizing these technologies really entails stitching together of these technologies in an end-to-end solution. And that is required to drive additional value, from this, and that's really at the end of the day what the objective of whatever you're trying to leverage these technologies for. So let's look at how all the different technologies, what they are, and how they are stitched together. You start with data. Today, there's lots of data available, and the big data. So the next step is really consolidating that data into a platform, using the cloud computing, edge computing, data lakes, platforms, connectors, and then you process that data, do the advanced analytics on it, using things like AI models, digital twin, hybrid models. And this is, of course, a very, very key part of the entire pipeline. And then, of course, the results that you get have to be presented in a form that can be easily consumed and utilized to get results. And that's where you have business intelligence tools, extended reality tools, and so on. And the industrial Internet of Things allows remote resources to be able to access and work with any of these. The end result really is decision quality insights coming out of all of this. It basically answers the could and should questions to address a business need or an opportunity. And that's obviously the key. Now, that could be addressed. There's, beyond this, there's an implementation step, which is, of course, exceptionally important in order to be able to end up with actions that really address the business need. And then you have workflow management tools, and you have interaction and collaboration between remote resources and local resources using collaborative tools, and of course the industrial Internet of Things, or I like to call it, the application is industrial Internet of People, because it is able to connect a lot of different people at different geographies. And then you could also have autonomous implementation using robotics or advanced controllers where the actions are automated. And actions basically answers the would question. So essentially, the end-to-end solution really transforms available big data to decision quality insights and hence smart actions that address a business need or opportunity. Now, developing data awareness and fluency is key to succeed and sustain any kind of these AI-based solutions. Now, let's look at a little deeper into the artificial intelligence, because this is really a key ingredient. Artificial intelligence has been defined as the ability of a machine to perform cognitive functions and things that we associate with human minds, like problem solving. And so here, some of the points to note are, a lot of the times in the recent past, AI has been considered synonymous with machine learning. But machine learning is really just a subset of AI. And of course, in the recent past, the convergence of algorithmic advances, computing power, storage, low costs, available data has really propelled AI from hype to reality. Now, AI helps solve problems that were perhaps not traditionally tractable and or solves them faster. AI augments the human intelligence with augmented intelligence in order to make better, smarter decisions. AI is a necessary component that enables value realization, and that is essential in any kind of digitalization initiative if you want to extract value. And last but not the least, implementation is the key. A lot of the times people just focus on the technology, but miss out on the implementation, and that could, how you implement it and the process you go through can make a difference between night and day on your results. Now, let's look at the augmented intelligence. I mean, that's a key result that comes out of artificial intelligence. Uses all this big data, does large multi-dimensional analysis, is really what artificial intelligence is able to do, takes care of time-consuming tasks. Some of the rote tasks are automated through autonomous applications. But above and beyond all this, it's really the augmentation of the human intelligence. And that's what enables the smarter actions, higher productivity, higher earnings, overall job growth, and so on. So essentially, I'd like to think of it like an intelligent assistant, and that's really what AI really does, and is the key result area today that AI brings to the table. Now, if you look at a decision process, a regular decision process, you have a problem or a need, and then you have decision analysis, trying to do the right thing, decisions, then execution, which is always important, doing things right, action, solution, outcome, and then a feedback. And then this is a whole loop of the decision-making process, hopefully improving as we go along. Now, with these AI-based solutions and the digitalization, essentially what you get become more data-driven. you look at a lot of the data, provide the decision intelligence, and then the augmented intelligence really helps improve the decision making and the decision analysis. So that's the whole place where all this fits into the smart decision process. Now let's take a look at a little deeper at the artificial intelligence. Now, like I said, artificial intelligence has, in the recent past, there's been a huge growth in the machine learning because of the reasons we mentioned earlier. And it has always been considered synonymous with artificial intelligence because of the recent boom in this area. And what is machine learning? It's really algorithms which use data, looks at patterns, and is able to predict behavior of the process or whatever the data is describing. And the algorithms are also able to auto-adapt in response to new data and experiences and improve efficacy over time. However, there's another part to artificial intelligence, and which artificial intelligence really started in the late 50s, and there, I mean, you had things like rules, causal models, domain experience, first principles, and this still forms a good space to value add and add to the machine learning. And some of the ways it does it is, in addition to having another dimension to the artificial intelligence, you can also help train the machine learning models better through transfer learning. When sufficient data may not be available in a certain dimension, you can really generate that data, synthetic data through the first principles. So that's what I call physics-informed machine learning. And so that's really what consists of what we call composite AI or interpretable AI. And that's really what gives us what I call the augmented analytics, which is real-time, auto-generated decision quality insights being generated, augmented intelligence, descriptive, diagnostic, predictive, and prescriptive in nature. And I'll show some examples of this. Now, let's look at the development methodology for AI models. I mean, again, like I said, it's not, I mean, the technology is there, but how you implement it and the process you go through is extremely important, which really makes a difference, in getting to the success. So all these various steps that I've shown here, you have data at the core, and then let's go through each of one of these steps. First, you start with a business understanding where you ask the right questions, set the business objectives, articulate the decisions to be augmented upfront, set expectations on the model accuracy, precision, and so on. Remember, identifying and solving problems at the use level and then working upstream, we found to be really a success mantra in this. Next step is data understanding, data quality, data sources, explore the data, beyond all, get the right data. Remember, using relevant data to train based on ML, the objective that you're using it for. The world represented by your training data is the only world you can expect to succeed in. And choosing training data that describes the reality you want to succeed in when you're doing data-driven models is really an important part of the data understanding and what you end up using. Next step is data preparation, where you process the data, prepare the data, split the data for your training, testing, define your inputs, and so on. Then you go to the data modeling step, where you select the algorithms, train the models, tune the models, set up adaptive learning models. Then you go to the validation and testing of these models, which is the next step, the retraining, performance evaluation. And then, of course, beyond all this, you have to operationalize the model, deploy it, monitor it, monitor for the performance, reliability, life cycle management. So that's all part of what the model ops function. And then these steps are really very important, because at the end of the day, people can tell you can plug and play technologies, get it done, maybe in less than a week. Yes, I mean, you can train and get a model up and running maybe in less than a week, but to have it really accurate, you need to go through some of these iterations multiple times to make sure you minimize the false positives and the false negatives, the accuracy, in other words. So this is really an iterative cycle with the data as the core. which you have to go through multiple times to really get to an accurate level of a model. And even after deployment, the frequency with which this cycle is repeated really depends on the use case. It could be, very infrequent, or it could be in real time, or maybe once a month, or whatever, depends on the use case. Now, to do all this together, and when you go through, taking in the technology and putting this solution together, having the right skill sets is very important, and this is often overlooked. So these are some of the roles. I've just put it as roles, and you could have the same person wearing multiple hats, or the same role really being split between multiple people. So I'll just quickly run through the roles. One is data engineering, where you define the data architecture, the data extraction, processing the data, and making it ready for whatever it's going to be applied for and used for. Then you have the model engineering, where you really build the models, use the right fundamentals where required, train the model, build the visualization, from the models. And then you get to the model ops, where really you have to deploy the models, operate the models, monitor the models, and make sure it is accurate. Apprise the business owner of the model performance, keeping the credibility and the comfort level up, and management of all these models as you go through. Another extremely important thing is the domain specialist and analyst, and this is very, very important. Again, often overlooked when you really get down into just doing the math. Domain specialist or analyst is required to understand the business need from the owner. They have knowledge of the domain engineering. They do the quality checks, ensure that the right questions are asked and the model is being used to answer the right questions. Ensure the right data is used. So they work with the data engineering group, so that end of the day, the right data is very important. Support value generation. And then, of course, the business owner, who defines the business need, reviews the solution versus the need fulfillment, does the change management to ensure the data-driven process, and so on. So the skill sets that you need across this whole pipeline that we saw before, if you look at it, all of these skill sets are really required right from the beginning to up to the deployment stage. They either play a lead role or a support role. And some of the key things is being able to select the right data, tools, and techniques, ensure the change management happens, the results tracking. And one key thing is the objective setting up front. Unfortunately, using the right math to answer the wrong question is a very common mistake in these ML-based applications. So the decision intelligence from the domain specialist and business owner and their close involvement through the process is key. And this is something we found out, which really made a huge difference. And then you have the data pipeline architecture. I mean, there's so many different technology stacks that are available. So depending on the use, you can mix and match, and depending on the client specifications, the client need, you can use various of these. So, it could be for streaming data pipeline or batch data pipeline. So, I mean, that's just the point I wanted to make without getting into a whole lot of detail on the technology stack here. Now, the business areas for application, it goes across all spheres of the business, R&D, design, supply chain, manufacturing, sales, marketing, market dynamics, finance. For this rest of this presentation, I will focus on manufacturing, and in particular, the process manufacturing. So there, the starting point is really data. And in this industry, in the process manufacturing space, over the last couple of decades, there's no dearth of data, with the historians and the DCS systems that we have. We've had huge volumes of data collected at a fair velocity, maybe second by second, and a lot of variety in the data: temperatures, pressures, flow rates, composition, and so on. And however, the veracity of the data, about 25% of the data is typically always an error, and unfortunately, you don't know where the error is. So that's the key challenge. Now, when you come to someone managing the operations, he or she really has to juggle between managing the throughput, productivity, quality, safety, compliance issues, the reliability, and so on. And the data, so far, I mean, typically of all this data collected, only 10% normally used to get used, and 90% was archived. And this is really where these, new digitalization solutions enable you to utilize a lot of this typically archived data as well, because that's where a lot of gems of information that gets missed out seems to lie. And so you start with a lot of key performance areas and indicators like reliability, emissions, profitability, overall equipment efficiency, safety, and so on. So now let me tell you a little bit about the Engineero solution. So using all these principles that we discussed, this has really helped us in deploying very successful solutions in the petrochemicals, crude oil refining, midstream, specialty chemicals area. Our solution that we have, we call iSpeed, which stands for Intelligent Software for Process Decision Excellence. Essentially, it takes data from different sources, makes it available using the IoT principles, converts it into directly usable augmented intelligence for decision making for operators, engineers, and management. Now, one of the key things, again, as I was saying, the process by which you do this is very important. It's not just about the technology. So technology are like tools, they're like atoms. You have to convert it into a solution that can directly give you the augmented intelligence. Now, taking those technology pieces, tying it all together and converting it into a solution, it's like converting an atom to a molecule. And that's what I call the decision excellence engineering process. And that is using, of course, data at the base. And that's really where the value comes from, being able to provide a solution that gives the augmented intelligence. Look at the various components at a glance. All the components we looked at, you have the data, then you have the various pieces like the data platforms, the AI solutions, the visualization, and then it can be deployed either on the cloud or on-premise or as a hybrid. And the deep process drives a lot of this, pulling it together, then setting it real-time, automated, running. And Engineero's relevant expertise and domain experience has been a key factor to be able to succeed with a lot of these deployments. Some of the capabilities at a glance of iSpeed, you have actionable intelligence, hybrid models, agnostic to the data source, false positive resistance. This is very important. And this is where the use of some of the fundamental models to use to guide the machine learning so that it doesn't go into domains where it really doesn't make sense. Financial optimizers, smart dashboards, it is real time, does multidimensional analysis, soft sensors where oftentimes when sensors are not available or they drop off, you're able to predict based on other information that you have. You have a lot of interactive dashboards depending on who the user is and what the use is. You have solution dashboards giving overview of the entire process, equipment overview, an overall financial impact overview, analytics of specialized KPIs that you're focusing on, or special key areas like furnace run length predictions, things like that. So various different kinds of interactive dashboards. Now, the benefits from all this really comes broadly from two areas. I call it, one is tactical, where you have direct quantitative results that can be directly implemented either through an autonomous implementation using, say, APC in case of process manufacturing, or direct quantitative results that could be actually given to an operator and directly implemented. And the other one is more of the strategic value, which is where you have intelligence and insights being provided to either the operator, engineer, or the management. And combine that with prior knowledge, they're able to go to a next level, a next step, and make a lot smarter decisions. So these are broadly the benefit realization channels, if you will. This is an example of an application where we deployed this at over 40 sites at a midstream company in the US. Key results, of course, the profitability increased by 15% in the first year, reached up to about 22% in the second year improvement. Of course, this required continual support from a centralized team driving implementation based on the augmented intelligence from the solution. Of course, the fact that the centralized asset information that was made available from all this, and the analytics that gave the augmented intelligence was obviously made a lot of this feasible. Obviously, there was improved quality and systematized identification and prioritization of the process and operations requirements was indeed very helpful. Here's another example of a dashboard, overall energy, giving at a glance view, which of course you can further drill down into where the energy flows, inflows come in, where they are utilized, where it's wasted, where it's generated, and so on. Here's another example of a dashboard showing overall asset effectiveness. This was from an actual deployment, where in this case, the benchmark was the design, which was considered as 100%. And in actuality, they were actually running at 107% of the design at this particular facility. However, the solution immediately came and, in real time was showing that you could really be running at 111% because they'd actually run, given a lot of the same conditions, at 111%. So identifying that gap, and then further also showing that ideally you could also be running at 112%. So identifying the gap and presenting that, and then showing how possibly you could close that gap is really what the solution provides. That's worth about, in this case, was worth about 10 million US dollars on an average per annum. Here's an example of an application on a furnace providing augmented intelligence using ML-based models, hybrid data model using some of the fundamentals as well, and it provides the burner optimization, which helped increase run length from 70 to 170 days. Increased production by about 5%, improved stability and reliability. And so you can see, if you look at the dashboard, various different aspects being covered, emissions, sustainability, key performance indicators like furnace run lengths, alarms and alerts, energy, fuel savings from the application of the predictions and prescriptions. So that's kind of a quick glimpse at one of these. I'll quickly run you through, give you a glimpse of an application of this ice speed to an ethylene plant. Here's an example of the landing page. This was worked together with the client in this case, showing a key overview of all the key performance indicators the client really wanted to see. Quick overview of the unit, showing a red, green, amber, classification of where you really need to focus on. You can certainly drill down into the various equipment and look at what needs to be done. A couple of examples. Here's one. What this enabled through application of the prescription and the predictions that came out from the solution. Improved yield, enabled about $15,000 per day improvement once the action was taken. And this came through the predictions and prescriptions from the model. Another example was extended decokes that were again possible from the predictions and prescriptions, worth $74,000 a day in this particular case. So just to wrap up, I just have some key take-home points to note from what we just discussed today. Certainly, digital augmented analytics using AI and ML can unlock significant value from data for smart decision making. However, only when key components beyond the technology are considered when implementing it. So implementation is really, really very important, which is often, just glossed over. Clarity of purpose for which the AI will be used and how it will be used is needed before starting. Ensure that the math is not going to be used to answer the wrong question. AI is not just ML, it's fundamentals plus data-driven ML, and that achieves the best results for a given objective. Technology selection and implementation considerations are think through end to end, from the data source to visualization, utilization, workflow, right at the beginning, figure out, lay it out, and of course, all working backwards from the objective. Base the AI ML modeling strategy, technology stack, implementation approach, and architecture on the objective. So the objective starting out is really very important. A domain specialist with a flair for analytics, we found, is fairly necessary from the start to the end of the project, collaborating with the stakeholders and computation engineering team to provide the necessary decision intelligence and to set the right objectives and also help select the right data sets for training. That is very important in any ML-based application. Always plan for the ongoing maintenance, which is the model ops. So it's not just about building a great model. Ultimately, it has to be deployed and it has to be reliably deployed and working. And match the use cases to the users to ensure the usage. Follow through on the value capture that you can typically estimate upfront if you know what you're trying to address as a business need through baselines and careful tracking. And here, last but not the least, and this is something we found is exceptionally important, is having an executive champion from senior management who can take ownership of the solution application and drive the necessary workflow transformation within the organization and ensure utilization, especially at the initial stages post-deployment. This we found to be very important so that at times there has to be a transformation from traditional intuition, knowledge, purely knowledge-driven to more of a data-driven kind of decision-making. And that requires some level of senior executive support. So, that kind of is really what all I wanted to say today. And so that I come to the end of the presentation.
Hi, Dr. Pratap. Sorry to interrupt you. Actually, we are running behind the time.
I'm ready to really answer questions,
Cool.
so I can stop sharing the screen. And
so we really sorry to interrupt between your session. We'll jump to question and answers. There are two questions. One is interesting one. What is the best digitization project you executed so far? How much did it cost, and what were the returns out of it?
Actually, there are several, but of course, I think the most recent one that we implemented was at a vinyls facility, where it was very focused 3 or 4 use cases, and to do that it was done in a period of about 3 or 4 months. Results were obtained. The return on investment was about 10 times very quickly seen, and now of course it's being scaled. And cost really depends on the application. It can vary from the tens of thousands to hundreds of thousands. For an entire facility, it could be maybe order of $1 million or so, depending on the size of the facility again.
Thank you. Another question is, digitization requires different skills on participation of projects, as has been the experience in commitment.
Yes, that's a very good question, and I think that's what I was alluding to. I'm glad you asked that, because yes, you have. While I mentioned all the skills, and I also mentioned, the involvement of the business owner and the people who are actually going to utilize the system. So their involvement right from the beginning and taking this up and sometimes changing the way things are done, because some of these solutions may entail doing what has been done in a different way. You don't want to automate inefficiencies by doing how things were always done before. So yes, the experience and commitment from the user side is also very, very important, and which is why I said oftentimes we found that having some senior level sponsorship oftentimes helps, and also for the all the teams to take ownership and have that commitment.
Great. Thank you, Dr. Pratap. The last question is, how you convince the customer to share the data with you?
Again, a very interesting question. We've done several of these now. Like I said, right from the beginning, even 20 years back, we've been doing data analytics, and we've had a whole spectrum of customers. Of course, I mean, you have a lot of very, very secure systems, customers coming and auditing how things are handled. But we've done it in various ways. There have been cases where the data access has been given on their systems, and we work remotely on their systems. There have also been cases where it's been in secure environments, and it could be remotely located. So it has really varied, and so it really depends from customer to customer. How they want things done, and how we can work together, the trust factor. And typically this is also works in phases. I mean, initially when you start, you find, there may be a lot more closeness. And then as you go forward, as the trust builds and the credibility builds, you find, and when you see, when the customer starts seeing more and more benefits coming from being able to share more and more information, you see more and more collaboration happening. And that's very natural and normal. And that's been our experience.
Great. Thank you for answering all the questions, Dr. Pratap Nair. Let's just check. Would it be good to show a demo? Thanks for this session.
Thank you. Thank you very much for attending. Thank you, Vatsal, for moderating.
Thank you, Pratap.
Thank you.
Have a nice day. We'll move on to the next session.
All right. Thank you.